Hey guys, my name is Sinesh from my tutorials web and welcome to the next part of the series of Visual Studio based on OpenGL. On my previous video we compiled with a basic example using the geometric primitives such as the triangle. So in this video we'll go with the functions such as the rotate function, the translate function and using the glrto2d function. So let's make some changes in our programming. Let's comment on the triangle function. We'll be using the quads, that's a set of 4 vertices. GL begin GL quads. GL color 3F. Let's take green in color. GL vertex 2F. Now if you don't know what does this mean, then I would suggest you to see on my previous video. Just copy this, paste 4 times. Since it's a set of 4 vertices, this is the positive x-axis and y-axis. Then we take negative x-axis and positive y, negative x-axis, positive y-axis, and then finally positive x-axis and y as negative. So just compile this. Sorry guys, we haven't ended the file. GL and yes. You get a quads. Now let's use the translate function. GL translate F. Now the GL translate F, it has 3 parameters x, y, z axis. That's shifting the object towards the x or y or the z axis. So let's shift towards the positive x axis. The z axis is not affected since we are working on a 2D object. Now if you just build solution, debug, start debugging, you see the difference. It has moved towards the positive x-axis of 0.5. If you give greater than 0.5, then say for example you give greater than 1, then it gets shifted towards the output of the screen because this is a 1 cross 1 matrix in our case. Let's use the rotate function. GL rotate F. It has 4 parameters. The first one is in the angle x, y, z axis. The angle is in degrees. So let's give 45. Since it's floating point number, give 41.0 f, comma 0 f, comma 0 point. The x axis will be 1.0 f. Yes. Build solution. Debug, start debugging. You see it has rotated to an angle of 45 degrees. Now let's call the void glshape function and you'll know what it actually does. Void glshape GL size I. It takes the default width and height of the output screen. If height is equal to 0, it's obviously not equal to 0, but if it's equal, then we make height equals 1. Since as you can see in the main function we have defined the window size to be a 640, 480, so it's not equal to 0. But if it's equal to 0, then we set height equals to 1, so to be it as 0. Then we set the glfloor aspect. It's nothing but the ratio of width and height. glfloor, the ratio of width to its height, width divided by the floating point number. And we set the viewport. GL viewport. It has 4 parameters: x, y, width and height. The x and y are the bottom left corner of the output screen. So it's 0.0, and the default width and height. GL matrix mode. Let's operate in a projection mode. Now in OpenGL, after every matrix mode, use the glload identity. Now why is this? Because now in our case we have used GL quads, and before this we have used the gltranslate function and the rotate function. So what it does is it shifts this quads towards the positive x-axis. Now if you use glload identity, it means that after shifting towards positive x-axis, this one becomes the current matrix and it moves into the stack. And if you use glload identity, it removes from the stack and remains its original position, that's 0, 0, to its original matrix. If width is greater than or equals to height, if it's greater, obviously it's greater in our case since we have set the window size to be as 640, 480. So width is greater than or equals to height. And if at all it's greater, this is GL ortho 2D, working on 2D. Now what it does is, now in OpenGL in model view we have two types of views, that's the ortho view and the perspective view. Now the difference between them is, say for example you have an object, and if at all if it's placed away from the observer and if the size remains same, that it means that the size is independent of the distance between the observer and the object. Then we say it as GL ortho 2D. And in the perspective case, it's like in the real world, if the object moves away from the observer, it appears to be smaller, and if it moves closer to the observer, it appears to be larger. So that's GL perspective. We'll work on perspective on the future tutorials. Now in this, the GL ortho 2D, it has 4 parameters, that's left, right, bottom and top. Left, right, x-axis, bottom, top, y-axis. Left 1 minus 1.0, we multiply by the aspect ratio, and the y-axis will remain the same, minus 1.0, 1.0. Bottom is negative and top is positive. Yes, okay, it's GLU ortho 2D. Else, that's if height is greater than width or the width is less than height, then GLU ortho 2D, that is in this case the x will remain the same but the y-axis will be divided by the aspect ratio. So minus 1.0, 1.0, minus 1.0 divided by the aspect ratio, 1.0 divided by the aspect ratio. Let's work on the model view. GL matrix mode, model view. As I mentioned earlier, if you use matrix mode, make sure you use the glload identity function. And then finally call the reshape function. Yes guys, build, build solution, debug, start debugging. You see the difference, it's much more clear than the previous output. So this was just a short video. I know it was boring, but let's make it fun in the next tutorial. If you have any questions, comments or concerns, go and post it below. I'm pretty good at getting back to everybody. If you like it, like, and most importantly, do share this video. Thank you.